So hello class 7 students, welcome back again. So from this video I am going to give you the exercise question and answers of the chapter acids, bases and salts. So let's begin then. The first question of the exercise: state differences between acids and bases. And the answer is, first point of acids, you see acids have sour taste. Okay, acids are, the taste of the acidic substances are sour. Okay, and the taste of the basic substances are bitter. That means bases have bitter taste. Okay, second point, you see acids are not soapy to touch. When you touch an acidic substances, you will not feel its soapy nature. Okay, there is no soapy nature in acidic substances. That means acids are not soapy to touch. But when you touch a basic substance, you will feel the soapiness of it. That means you will feel the soapy. Okay, bases feel soapy to touch. Third point, you see acids turn blue litmus to red. When you dip a blue litmus paper to an acidic substances, then the color of the litmus paper will change to red. Okay, in the same way, when you add or dip a red litmus paper to a basic substances, then the color of the litmus paper change to blue. Okay, that means acids turn blue litmus to red and bases turn red litmus to blue. So these are some of the differences between acids and bases. Next question: ammonia is found in many household products such as window cleaners. It turns red litmus to blue. So what is its nature? You understood the question? That means ammonia is found in many household products such as in window cleaners. Okay, and it turns the red litmus to blue. Okay, ammonia turns red litmus paper to blue color or red litmus solution to blue color. So what is its nature? You have to identify, you have to name. That means the answer is what? Ammonia is basic in nature. Okay, because bases turns red litmus to blue. That is why the nature of the ammonia is what? Basic. Understood? Next question: name the source from which litmus solution is obtained. What is the use of this solution? Okay, and the answer is, you see, litmus solution is a purple colored dye which is extracted from a type of plant called lichen. Okay, from where litmus is obtained? Litmus is obtained from lichen. Okay, and what is the use of the solution? Litmus solution is used as an indicator, right? Litmus solution is used as an indicator. And what is an indicator used for? Indicator is used to determine the acidic and basic nature of a solution or of a substance. Okay, so litmus solution is used as an indicator to find acidic and basic nature of a solution. Okay, clear? Next question. Question number 4. Is the distilled water acidic, basic or neutral? How would you verify? First of all, you tell me the distilled water is acidic, basic or neutral. It is neutral, right? Distilled water is neutral in nature. And how we will verify? See the next paragraph. We can verify the nature of distilled water by putting the red litmus paper and blue litmus paper in distilled water taken in a test tube. First of all, if you take a distilled water, some amount of distilled water in a test tube, and if you add or if you put a red litmus paper to it, if you add or if you put a red litmus paper to distilled water, then there will be no change in the color of red litmus paper. Similarly, if you put blue litmus paper in distilled water, again there will be no change in the color of the blue litmus paper. That means distilled water has no effect on any litmus paper. Since it has no effect on any litmus paper, that means what? It is neutral in nature. Okay, so this is the answer of question number 4. You can pause the video and you can note it down there, all the answers. Okay. Next question. Describe the process of neutralization with the help of an example. What is neutralization? Neutralization is the reaction between acids and bases to produce what? Salt and water. Okay, so here is the answer. Description. You have to describe the process of neutralization with the help of an example, remember. So here is the answer. When an acidic solution is mixed with a basic solution, then what will happen? Both the solutions will neutralize the effect of each other. Okay, the acidic nature of the acid will be destroyed and the basic nature of the bases will also be destroyed. Okay, both will cancel the effect of each other, they will neutralize each other. Okay, so what will be the product? The resulting solution, the product, will be neither acidic nor basic. Okay, so in neutralization reaction, heat is always produced or evolved, which raises the temperature of the reaction mixture. If you add acid and bases with each other, then they will cancel the effect of each other, they will neutralize each other, and the temperature of the mixture of acids and bases will be raised. Okay, heat will be produced. Clear? Also, a new substance is formed in this reaction. What is the name of the substance? Salt. And salt may be acidic, salt may be basic, or salt can be maybe neutral in nature. Okay, thus the definition of neutralization is what? The reaction between an acid and base is known as neutralization. Salt and water are produced in this process with the evolution of heat. Clear? And the reaction, which you have to note it down, that acid plus base forms what? Salt and water. Salt plus water, also heat is evolved. Clear? And the example of the acid, which is given from the book only, and the example of the acid is what? Hydrochloric acid. Okay, this is the example of acid, hydrochloric acid. HCl is the formula of hydrochloric acid. Similarly, the example of base taken is sodium hydroxide, and NaOH is the formula of sodium hydroxide, which is a base. The product is obtained is what? Salt. That is, what is the name of the chemical name of the salt? Sodium chloride. Clear? And the formula of sodium chloride is NaCl. Okay, formula of sodium chloride is what? NaCl. And what is produced here? Water. And the formula of water is what? H2O. Clear? So this is the this is the reaction, or say answer of question number 5. Okay, next question is there. Okay, next question number 6. You see, mark T if the statement is true and F if it is false. The first question of question number 6, Roman number 1, nitric acid turn red litmus to blue. Is it true or is it false? Now you see, nitric acid is what? Acid. So acid will turn red litmus to blue, or what? Here it is asked. Okay, now you know that acid is what? Means acid turns blue litmus paper to red, right? Acid turns what? Blue litmus paper to, or blue litmus solution to red color. Okay, acid will not change the color of red litmus to blue, so it will be what? False. That means you have to write F over here. Clear? You have to write what? F. Understood? F for the first question of question number 6, Roman number 1. Similarly, second question of question number 6, Roman number 2, sodium hydroxide turns blue litmus red. Again, sodium hydroxide is what? Sodium hydroxide is a base. Okay, so bases turns red litmus paper to blue, or red litmus solution to blue color. Bases will not change the color of blue litmus to red. Blue litmus to red. It will not change its color. Okay, so what you will write again here? False. F. Okay. Roman number 3. Sodium hydroxide and hydrochloric acid neutralize each other and form salt and water. Right. Sodium hydroxide is again what? Sodium hydroxide is a base, and hydrochloric acid is what? Acid. So again you see, base plus acid. Base reacts with acid to form what? Base reacts with acid to form salt and water. Okay. Acid and base reacts with each other to form salt and water. Similarly, bases and acids reacts to form salt and water. Okay. So this statement is what? Then true, right? Sodium hydroxide is a base, hydrochloric is acid. They will neutralize each other and they will form what? Salt and water. So the answer here is true. Okay, this statement is true. Okay, next, Roman number 4. Indicator is a substance which shows different colors in acidic and basic solutions. Again, this statement is what? True. Why? Because indicators are used to determine the acidic and basic nature of solutions by changing its color. Okay, they will change its color. Example, for example, lots of indicators are there, man-made indicators like litmus, like China rose petals, like turmeric. Okay, also phenolphthalein is a man-made or synthetic indicator. All these indicators, they are doing what? They are changing the solution. They are changing the color. Indicators changes their color to show the acidic as well as basic nature of the solutions or substances. Clear? So this statement is what? True. Question number 6, Roman number 4. Next, tooth decay is caused by the presence of a base. Now, tooth decay is caused by the presence of a base, or what? Tooth decay is caused by the presence of acid. Okay, not base. Bases are used to cure tooth decay. Okay, so this statement is what? False. F you need to write up. Clear? So this is question answer. These are the answers of question number 6. And the rest of the answers of question number 7, 8, 9, 10, 11 I will provide in the next video. Okay, so that's all for today. Thank you and have a nice day.